Welcome back, everybody, for the second stretch of talks on this amazing day of React Everything. I hope the coffee helped in revitalizing your spirits, refocusing your attention for the next speaker. The man is a pretty well-known face in our Amsterdam scene. He has been doing many talks in the past at various meetups and conferences in the region. He's an Italian guy living in Holland, working on Balsamiq, the wireframing app. Stefano, come up on stage. You can connect your laptop while I'm introducing you. Yeah, he's been working with a pretty seriously cutting-edge stack for their new app. React, Redux, Relay, GraphQL, Node, Redis, running on AWS, and using Convox to deploy the thing. So I think, like Jessica in the previous talk, this is going to be a talk of some war stories, sharing what he has done to make all this happen, and especially GraphQL and Relay, what the state of that technology is nowadays in a real-life web application. Please give it up for Stefano Masini.
Thank you. Hello. So, yeah, my name is Stefano. And, yeah, I'm the only one in Balsamiq living here in the Netherlands. We are all work remotely. The title of my talk used to be about Relay, but then I realized it was more about GraphQL, so sorry about the last-minute change. Yeah, just to give it away really quickly, it's been awesome. So, just out of curiosity, how many people here have heard about GraphQL? All right, keep your hands up if you've used GraphQL somehow, and now keep it up if you've used it in production. All right, those are just way too few hands, because GraphQL is really cool. So you should definitely check it out. So let me tell you a little bit about GraphQL, just really quickly. First of all, it's an alternative to REST. So it's a different way to fetch data from the server to the client. And it's space efficient on the network because it's the client that asks the server specifically what information needs to be returned. And so it's not like you have a normal entry point and you get a big blob of information regardless. The client can specify, and so it's efficient on the network. But it also turns out to be a really nice way to specify the data requirements of your React components. And it also turns out to be also a nice way to organize the code on the server. So I will show you a little bit of that later. So this is what a query looks like. Basically, it's, the best way to describe it is just a JSON without the values. And so, yeah, so this is the way a query looks like, and the response looks like, the filled up JSON. So you get the information back from the server, exactly what you asked for. And so GraphQL is built around three major concepts. One is a query, which is the way to read information from the server. One is a mutation, which is a way to write to a server and change the server-side state of the application, kind of like a remote procedure call. And then the most recent addition is subscription, which is a way for the server to send push notification, push events to the client. And just to make sure, to be clear, GraphQL is just a transport layer. It's just a way to exchange information, data with the server. Then you still have the problem of dealing with the application state. And for that, there are libraries like Relay or Apollo. And since just a couple of days, Relay Modern, they just announced a new version of Relay, and they called it Modern. So now you have Relay Classic and Relay Modern. It's 0 or 1.0. It's just a new version. And these libraries take care of allowing you to specify the component data requirements, your React components, and dealing with the communication, so you don't have to refetch if the server wasn't answering for some reason, and caching, most importantly. So, this is just, a really quick introduction to what GraphQL is, and in the ecosystem around it. But do look it up, because it's really interesting. Now, back to the story of this talk. As I said, I work at Balsamiq, and so you may know our tool, which is a tool for creating wireframes. And this is typically a desktop application, what most people knows us for. But some of you may know that we have an online version of it that's called My Balsamiq. We've been busy in the past year and a half. Well, we rewrote the whole thing in JavaScript because it used to be Flash. So that's the biggest effort, something that my other colleagues are talking about in other conferences, also very nice talks, about how we rewrote the whole thing. But what I'm talking about today is the effort of writing a new online application, Balsamiq application, which is this one. It's called Balsamiq Cloud. And it's basically metadata containers. It's a place where you can put your Balsamiq projects. And so you have a way to store your projects. And then if you click on the projects, you can actually edit them with the editor that you're familiar with in the browser. And then you can collaborate on the project. So you also have people in your site. So you have a site, we have people, we have projects, and then of course we have a site settings where you can set, the name of the site. A site can have multiple owners. So it's that kind of application. Just, a container for projects. So just to give you a few numbers, we're talking about 26,000 lines of code. But the actual editor, the thing that you can use for editing the mockups, is 130K. So not too big, not too small. It's an interesting size. There are about 30 external dependencies, actual libraries that provide some feature that we really needed. But then somehow we ended up listing in package.json 150 modules, which blows up to a whooping 860 modules when you install in Node modules. That's the world we live in. We all know that. 200 React components spread around 50 files. 32 GraphQL mutations. So it's 32 different ways you can change the data on the server. 25 events. And then we have about 80% coverage of the server-side code with 120 integration tests. So this is our setup. And let's see a little bit about the architecture. So the whole thing runs on AWS. And in order to make sense of this crazy set of services they provide, we use a tool that's called Convox. If you don't know it, look it up. It's interesting. It's a nice way to make sense of all the mess. Then we have a GraphQL entry point, of course, the main entry point to our application, which builds on top of a schema. So if you don't know GraphQL, that's what you write. A schema is what you write in order to provide a feature. And then the resolvers of the schema hit on the database going through a Redis cache. We make heavy use of the cache. If it's warm, we don't expect many hits to the database for read operations. And we like to keep separate the definition, the part of the schema that defines properties that you want to read from the mutations, which are the writes that have side effects. We like to keep them separate in separate files. It's nice to have, in your code base, a clear separation of the portion of the code base that is only read and the portion that is side effects. Another thing that we like is, just like in a good old C language, programming language, where you have the .h file, which describes the types, and then the .c file, which describes the implementation. Similarly, we like to separate the mutations into the type definition itself and separate it from the actual implementation. So we call the implementation operations. because that's what they do. They operate on something. And we have, it's nice to have them separate also because not only can you call them from the GraphQL entry point, but you can also call them from other HTTP entry points. Which we do, for example, when you accept an invitation. So you have a URL, you click, and that's what happens on the server side. And the operations is actually where the real meat is, of course. That's where we actually write to the database or send an email or deal with the payment process or send out notification, this kind of stuff. So this is the overall architecture, and in general, everything has been developed according to the hexagonal architecture, which is a pattern. If you don't know it, look it up. It's interesting. It's basically a pattern built around the concept that if you have an external library, an external dependency, you only ever import that library in one module, and that module simply implements a little wrapper around the external library API to provide an internal API. So you make a little point of indirection between your code and the library so that if the library changes, upgrades or whatever, you figure out it's not adequate, you want to change it, you only have to rewrite the adapter and then the rest of the application keeps using the same internal API. It's really nice. It worked really well for us. We have about 19 adapters in cloud. And we wrapped everything from authentication, caching, database, logging, you name it. So we don't have, all of these dependencies are only in one place in the code base. If we want to swap out the library for one of those features, we just replace that single module. And those adapters are made available through the rest of the application through dependency injection. So instead of relying on import statements, we mostly rely on parameters being passed into functions. And these instances are made available through the GraphQL context. So let me show you a little bit of code. Don't be intimidated by this amount of code. You don't have to understand this, also because it looks very similar to what you find in the examples you read about GraphQL. Basically, it's a type definition. This is what is a project in our schema. And so you can see a list of fields. These are the fields that are accessible through the GraphQL schema. And basically, this is just a way to define the type and the resolver. So in order to get, for example, the thing that's called properties, there's a function that's called a resolver, and which is this one. And what you just need to notice here is that even though this is a function, it could have been like this big, we decided to make it this short because of the same reason I said before. We like to keep the definition of the type separate from the implementation. So inside the type definition, we just place one function call. And we just wrapped it with this little thingy that we created. It's called a resolve with logger. It's just utility function that intercepts maybe exceptions and report them in a nicer way than the bare-bone library would have done otherwise. Just utility. So this is what our type definition looks like. This is what a mutation looks like. This is indeed a little bit different than what you see in the documentation. Of Relay, for example, because we leverage a naming convention with this little helper function up here. We have, as I said, we have a convention in our code base where we like to keep the definition of the type separate from the implementation, and we call the implementation operations. So basically we have one directory that contains JavaScript files called mutations. It contains JavaScript files that define the mutations, and then a different directory called operations with files of the same name that contain implementation functions. And so this is, as magic as it gets. We just like to leverage this naming convention with that utility function. Something useful we found to write a little bit less code. If there's one thing that people sometimes complain about Relay and GraphQL is that it's a little verbose. So this is just a little way we found to write a little bit less code. This is what an operation looks like. Again, don't try to make sense of it. Just notice that these are the adapters. This is dependency injection, right? So we pass a lot of adapters into the functions because that's how we use them down there. So we just place method calls on those adapters. So for example, you will not see like SQL code in this function because SQL belongs to the realm of the database. And so just like everything else, it's been wrapped in its own adapter. It's nice to have one single place in the code base with all the SQL there. If you want to optimize, that's the place to go. So instead of having it scattered around. So that's a nice thing we found out. This is another topic about how we write these operations. This is just a couple of sanity checks that throw errors. And we learned that for throwing errors, instead of just raising an exception, we raise a little bit smarter kind of exception that has 3 pieces of information. One is a simple text for the user, so something that actually is shown in the UI, and that's just used to indicate the next step. It could even be like write to customer support, you know. So it shouldn't contain any detail not to scare the user away, or also to not give away too much information to malicious users. So no internal IDs, nothing like that. That belongs to a second piece of information, a string that only goes to the server logs. There you must be as detailed as possible because it's useful for debugging. And then finally, a unique error code, which is a string that goes together with the first one to the customer. And we find this useful because when they write support, they cut and paste the error, and so it's nice for us to see exactly in the code what triggered the error. We make sure that these are unique. So the next thing I wanted to talk about is reactivity. And reactivity, reactive are all very popular words this day. The meaning I'm talking about today is when you're looking at a site, a page of an application that contains information, and some of that information is changed from another browser, from another user, whatever, you expect that page to update, right? So this is the kind of things I'm talking about. So let's make an example. For example, let's say that we want to change the user avatar. I have 2 browser tabs in my application, and from one I change my own user avatar. So I'm expecting the other browser tab to display the new image. So how do we go about doing that? Of course, we need some sort of WebSocket to channel events from the server, right? Something like that. So one naive way to approach that is that the client sends a mutation on my second tab to change the user avatar, and then the server changes the avatar and then sends an event on the application channel that my React components listen to. So when they mount, they listen to these events, and when they see an event, they force fetch. Force fetch is the mechanism for relay to just force reloading the information from the server. And it's a way to just, force updating everything. So that, of course, works, because if you implement it this way, your whole application will just reload the whole thing, and so, of course, it works. If you want to do better, then we can have more specific events. So instead of firing a generic event, we fire a user avatar changed event. So that our components can actually listen. So the user avatar component will actually listen to the user avatar changed event instead of every possible event. So that limits the amount of force fetches. Another way is to have narrower channels. So instead of having a generic application channel, we can have a user channel that's specific to myself. And so that user avatar changed event is sent through my user channel. And so only the user avatar component will listen to that channel, and so that will also limit the number of force fetches. But if you start to think about this in your application, this quickly becomes a hairy mess, because it's about the inherent complexity of your application. So, for example, let's take a look at this page. As I said, a site can have multiple owners, right? And owners are also users. So if one of those users, so this site specifically has two owners. If one of those users changes their name, I'm expecting this page to update, right? So what does it look like? So this is our page, simplified. As we said, the user avatar is just listening to the user channel. If I change user avatar on the server, then I fire an event on that channel, and therefore the user avatar updates. Now, talking about these two guys over here, these two combo boxes. Now, they will have to listen to the channel of the user that they're currently showing, right? And so when on the server I get a change username action mutation, then the server will just fire an event on the channel of that user, and that will solve the problem because the UI can actually update. But then, if you think about it, this is quite complicated on UI because it means that those combo boxes will have to register to that channel. But then, if I change the user on the combo box, I have to deregister for that channel, register again to another user channel. It's not very nice. So a better way to deal with this is maybe having on UI a channel for the page, for example. And so this is a site, so we can have a site channel, for example. And so we can just assume that the server will send the relevant events and will only listen to that channel. Of course, this is pushing the complexity to the server now, because when I change the username, I fire the event on the user channel, but if that user also happens to be an owner of the site, then I have to also send an event on that site's channel, right? So you see that we're just moving the complexity from the UI to the server. But I claim that I think this kind of complexity is better. It's better to have it on the server than the UI. It's better to keep the UI simple. So. Just to wrap up about this reactivity topic, we know that Relay Classic, which is the relay that we have out there, doesn't provide any solution out of the box. You have to implement your own thing, pub/sub plus force fetch, like we did, which is a solution, but it's inefficient because force fetch is not a nice way to deal with this. Just because there's just too many round trips to the server. You get the event and then you go back to the server to fetch again, so 3 round trips instead of 1. Relay Modern and Apollo instead provide GraphQL subscriptions, which are a much better way to deal with this because you can specify exactly what events you want to listen to and exactly what information you want to get back from the server when these events are fired. So it's an improvement over force fetch. But it's kind of new stuff. Live queries is a promising topic, but it's still an open discussion, so we don't know. Basically, the bottom line is that this is an inherent complexity. You somehow have to deal with it. The tooling that is out there that is getting more and more mature is only helping us to solve the UI part, which is good. But keep in mind that this stuff is complex, inherently complex. Now, a couple of words about testing, something else we're really happy about, and we think that GraphQL is really well suited for. So our tests look like, very simply, the test starts, then we regenerate the whole database on a real instance, a local instance of the database, go through the setup phases. Then we send a GraphQL request, the server answers, we check the results, and then go through a cleanup, destroy the database, and go on with the next test. So you would say, this could be quite expensive because it goes through an actual database with real, the real code that hits the real database and real cache. We only mock the external services like sending an email or notifications and that kind of stuff because we don't care about testing those APIs. But really, this only runs in 200 milliseconds per test. And we have 120 tests that run in less than 30 seconds. For integration testing, this is really good. We're really happy. And it gives us a lot of confidence that we don't have major bugs in the server. So also look it up. GraphQL is really good for testing. Now, we were really happy about this project because it was starting from scratch. It was a greenfield project, and so the first thing we started to do was look out, what was available on the space of the newer libraries 1 year and a half ago when we started. And you find a lot of stuff that claim, you to be productive with cool solutions like naming conventions, so that you have to write less code, default behaviors, less configuration, automatic stuff here and there, like caching, and you don't have to think about that. And maybe you have an ORM. I don't know. There's lots of interesting, cool, libraries out there and frameworks that are really advanced, because writing this stuff is not easy and really cool. But this all belongs to the realm of magic. And I don't like magic, because when I write something that I want to maintain for possibly a long time, I tend to forget the code and especially the magic. When I go back to my code that I wrote 6 months ago, and there's some magic in it, it inevitably gets in the way. So I'd rather prefer the code to be unsurprising and predictable as much as possible. So, welcome boilerplate if that means, I will not be surprised. Explicit configuration is good. Caching is a hard beast, so you have to bite the bullet. And plain SQL, why not? It's much easier to optimize. So this is all stuff that is normally considered uninteresting and repetitive, but it's safe. So I would rather go safe than sorry. So the bottom line, I guess, is you have to be cool, because relaying GraphQL and this kind of stuff is really cool technology. But play safe. Adopt sound engineering principles, and yeah, that was it. Thanks.
Thank you. Thank you very much, Stefano. Thank you very much for taking away some of the fear, uncertainty, and doubt around GraphQL for us. I would suggest we have time for one single short question, and then we have to move on. Here in the front.
I'm happy to talk about GraphQL anyway, all the time, so just find me.
Hi. I would like to know, what do you use to translate GraphQL query to SQL?
There's no direct translation. GraphQL doesn't provide, it's just a way to structure your entry point in your application. So you know what the client queries, you know what the client wants, but then how to fetch that information is totally up to you. So you can, if you have, you can conceive, for example, an ORM system that automatically takes your database schema and makes it available as a GraphQL entry point. That could be an exercise, an interesting exercise. But in a real-world application, I think it's better if you just write all the steps and go and make the query. So we have nothing magic in there. We just have really plain SQL queries that fetch the data that's needed. Then you have to be careful about not overfetching and not going to the database too often. So there's a very nice library that's called Data Loader that prevents it makes it easier for just more efficient. So look it up. But
Thank you.
It's an interesting topic. Thanks.
Thank you, Stefano. One last warm round of applause for Stefano.